Welcome to AI Frontiers. This episode presents the Intelligence Engine, Steering AI's Next Chapter, a deep dive into 62 research papers from December 4th and 5th, 2025. We will uncover the grand themes and quiet revolutions shaping the future of intelligence, moving from pattern matching to genuine comprehension and collaboration. This is a diagnosis of a field coming of age. This presentation provides an overview of navigating the research deluge. It maps the dominant themes across 62 diverse papers, explores key findings that illuminate critical breakthroughs, examines the methodologies driving today's discoveries, spotlights 3 seminal papers that define current directions, and charts the future frontiers of artificial intelligence research. The field of artificial intelligence is maturing. It is defined as creating systems that perceive, learn, reason, and act. The field is transitioning from adolescence to adulthood. It is no longer just about scale, it is now focused on reliability and understanding. Researchers are building the infrastructure for intelligence to operate in the real world, designing control systems, navigation instruments, and safety protocols. The first major research theme is the pursuit of robust reasoning. The community is revolting against shallow pattern matching, demanding genuine understanding, not just correct answers. Shima Imani and colleagues introduced dynamic benchmarks, SymPyBench and Prism. These tests require executable Python code, making memorization impossible. Edward Chang argues for a coordination layer to systematically use knowledge, stating we have a vast library but need the librarian to synthesize information. The second theme is architecting agentic systems, representing the double-edged sword of AI autonomy. The term agent is everywhere, describing systems that perceive, plan, and execute. The ARCANE framework by Charlie Masters and team reimagines alignment as a multi-agent collaboration, using interpretable, English language rubrics for transparent control. Warning papers like Chameleon and Astride explore hacking these very agentic systems. The field is architecting potential digital beings and must build their immune systems from the start. The third theme is building trust through human-AI partnership, with interpretability as the foundation for collaboration. Leon McGee and colleagues argue for an inspectable semantic layer where every decision is backed by citable evidence. The MIND framework gives multimodal models the ability to understand, rethink, and correct their own reasoning. Lucas Widener's team critiques current benchmarks, proposing to evaluate AI as full research partners. Jason Weston champions AI and human co-improvement as the safest path forward. The future is not human or machine, it is human and machine working in concert. Several key findings stand out like lightning strikes. Federico Bianchi and team documented a 55% increase in factual errors in AI conference papers from 2021 to 2025. Ziyuan Ma and team showed evolutionary pressure can unlock systematic reasoning abilities in smaller models. Ganvi Leroy and colleagues demonstrated that transparent medical models for autism detection outperform black boxes, achieving 97% sensitivity versus 90%. Truong Tan Hungwin and team achieved a 13% performance gain using quantum enhancement for real-world optimization. Robert Yang framed AI inconsistency as acrasia, or weakness of will. The methodologies represent a craftsman's toolkit. Agentic frameworks use teams of specialized subagents, like a film crew. Benchmark generation via programmatic synthesis creates infinite problem variations to test generalization. Knowledge graph augmentation uses structured networks to anchor the fuzzy knowledge of large language models. Model-based search, like Bayesian optimization, guides expensive experiments. Mechanistic interpretability involves observing AI brain activity over time to understand behavioral dynamics. A paper of the day is by Quigley and colleagues from 2025, titled On Measuring Grounding and Generalizing Grounding Problems. It turns the philosophical symbol grounding problem into a practical engineering audit. The paper proposes 5 desiderata: authenticity, preservation, faithfulness, robustness, and compositionality. It reveals that large language models have correlational faithfulness but not etiological faithfulness. Their knowledge isn't causally linked to real-world interaction. This provides a common scorecard for evaluating true understanding and explains why scaling text prediction alone may never achieve world understanding. A seminal paper is by Charlie Masters and team from 2025, titled ARCANE, a multi-agent framework for interpretable and configurable alignment. It proposes a paradigm shift, treating alignment as a multi-agent collaboration. The system represents human preferences as natural language rubrics, similar to grading criteria, which it learns to reconstruct from human feedback. This allows for real-time editing of objectives, such as stating, "I care more about thoroughness than speed." It moves alignment from a static, opaque process to a dynamic, transparent conversation. A visionary blueprint is Edward Chang's 2025 paper, The Missing Layer of AGI, From Pattern Alchemy to Coordination Physics. The central thesis is that critics confuse the ocean, the vast pattern repository of a large language model, with the net, the missing coordination layer. Large language models provide System 1, fast, intuitive, associative thinking. The missing component is System 2, a coordination layer to organize patterns for goal-directed reasoning. The paper proposes the UCCT theory and the Macy architecture with modules for baiting, filtering, and persistence. It reframes AGI challenges as solvable engineering problems in coordination. Future directions point to several critical frontiers. These include AI governance and metascience, with tools for continuous auditing of research integrity. Neuromorphic and hybrid architectures will create a parliament of different cognitive systems. Causal and mechanistic interpretability will transition from academic interest to industrial necessity. Human-AI co-improvement will develop concrete interfaces for seamless feedback loops. Key challenges include coordination complexity, evaluation gaps for safety and ethics, and maintaining socio-technical rigor. In conclusion, the story of December 4th and 5th, 2025, yields three key takeaways. First, the era of monolithic models is over, the frontier is now defined by the orchestration of multiple systems. Second, trust is the new benchmark, performance is table stakes, while interpretability and reliability lead. Third, AI is becoming a specialist and partner, acting as a domain-aware apprentice in human workflows. The field shows a healthy tension between capability creation and responsibility, building not just artificial intelligence, but a new kind of shared intelligence. This presentation was created through AI synthesis and review. Content was synthesized from 62 research paper summaries using a large language model. Text-to-speech synthesis was powered by Amazon Polly for audio narration. Visual concepts and slide imagery were generated using an AI image model. A human expert reviewed the synthesized content for accuracy and coherence. It is important to note that while reviewed, potential oversights may exist. All references to the original papers are provided. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by the arXiv preprint server.